Good evening, everyone. Welcome to this webinar series. We are into our 30th talk. Today's talk is going to be done by Professor Ishwaran Subramaniam, Sub as we call him. He's a research professor at Carnegie Mellon University and also associated with the National Institute of Standards, NIST. And he has worked largely in the area of design history, personalities, design theory, and also did consultancy and practical work with industries like ABB and Bombardier and some of these large companies. And the more recent one was with Chevron. So he's going to speak about the journey of Edison, who is more like a system builder. So with that, I'll turn it over to Sub to start the presentation. Thank you.
Thank you, Sudhir, for the introduction. And I hope you can see my screen now. Yeah? Can you see my screen?
Yes.
Okay.
Yes.
Thank you. First of all, I want to say two things. I'm not a historian.
Hello.
I study these things from the point of view of understanding how people like Edison
Hello.
or
Hello.
Da Vinci or other designers of artifacts and so on, to get an idea of how they think and how they go about doing what they accomplish. So Edison was born in Ohio of Dutch origin. He was educated at home by his mother, but he was an incredibly avid reader, and he used to distribute newspapers. And the first thing he did while working as a telegraph operator in the trains is to send the headlines ahead to the next stop. That dramatically changed the way the number of newspapers were bought. So he essentially created a demand by sending headlines ahead of time. He used to have a chemical lab in the train and experimented with telegraph and chemistry. He actually had an accident because of which he became partially deaf as well. From early on, he always kept in touch with other people to find out what the real problems they were facing. And slowly he started tinkering with things. And this is something, tinkering with the telegraph. And then that led to his first invention, which was not any modification to the telegraph, but was a voting machine. I won't go into the American politics of filibuster, but it's a device by which they could stop legislation. So in effect, he invented a voting machine first. But then he has a very strong theme that he will work only on things that society needs and relieves drudgery. And that was an important component of the way he thought about devices, systems, and so on. I'll come back to this slide later, but he was the first person to create an R&D organization in the world. He called it the Innovation Factory. There were machine shops. There was purpose in the type of problems. He assembled the right people, and so on. I'll come back to this slide later on. Okay, there was already a duplex telegraph in place. The problem was, how do I send messages simultaneously through the same wires, right? So he created this quadruplex. So you can see the diagram on the side from his patent. And so he would change polarity and increasing and decreasing the current for the other direction so that he could make it work both ways, actually 4 ways. Well, he was also working on other things. He was not just working on the telegraph. Now what I'm going to do is I'm going to use something called CK theory, which was created by some of my colleagues in France. And I wanted to see whether I can use this to explain the record of the invention of the telephone. Incidentally, Edison invented a telephone also, but all the telephones you have encountered since before smartphones, those heavy old phones, they are run using Edison's technology, even today, if you have those phones. So essentially, in this theory, there is a concept space and a knowledge space. And I've added people who contributed to each other's work in developing the phone. So initially, there were two periods in the telephone invention. The first person in the US was Gray, who invented a telephone with variable resistors using liquids, and Bell did something like that, and then came Edison. Rice was the first one to understand certain basic issues in the phone. We'll come to that. So already he sold his quadruplex machine, and he knew about the use of sound and electricity already. So now Gray had demonstrated a new harmonic telegraph using several acoustic tunes. Now it went from one sound to multiple sounds, which is what Gray managed to do. Bell actually patented his phone around the same time with a similar notion, but there is a huge debate over who did it first because of the stack of patents. Bell's patent was submitted last, and it got checked in because patent is based on who files first, and Gray lost the game anyway. Meanwhile, Helmholtz in Germany had created an electromagnetic device to produce different vowels. Now you can see there are different pieces that are coming together. In 1877, Western Union funded Edison to create a telephone to improve Bell because they thought they had lost the telephony market. So what are the main concepts here? Sound and electricity relationship, potential for carrying voice using electricity, problem of multiple messaging in telegraph, varying resistance by dipping electrodes in water or glycerine is good. So these concepts were there, but what did Edison know? Edison knew about duplex and multiplexing system. He knew about variable rheostat and Helmholtz device. Now, Rice's device was geared to understand complex sounds. So that is why concept of multiple sound. But this was given to Edison by Western Union because this was done in Europe. And then Legat, Prussian telegraph, had created a prototype and was starting to use Rice's device concept. So now he need to produce soft and loud tones. It's not differential tones at the same amplitude. It has to be at different tonalities, right? That means he has to extend Rice's phone. But then Rice was using intermittent current because he was just doing the tones. So he substituted it with continuous current and variable resistor to change the flow of current. This he understood, right? The use of relatively stable components. This is very important. As a designer, what he's doing is not changing everything. He's trying to keep all the relatively stable components while substituting other components where he can improve the pieces. So I won't read this out. Basically, it says that this is what Bell's telephone does. And what Bell had done, he had already understood that he can create a vibrating armature, a coil, and then he can create those vibrations, and that will induce electrical pulses which can be sent across, and variation in the magnetism on the other side, which makes the diaphragm move. Okay? So in a way, Bell's invention was that you can use the same apparatus to transmit and receive. This is an important piece of information, right? Now, what was weak about Bell's telephone? Lack of soft and loud sounds, no variable resistance. It couldn't go very long. It was limited by line resistance, so no power source, right? So this is Reese's phone. You know, you talk from here, and then that's transmitted, and that this diaphragm vibrates over the magnetic coils. And this was Helmholtz. What did he do? He did the same thing in a way, but he connected it to a tuning fork and changed the size of the different, what do you call, coils as a way to produce different sounds. So this is another rendition of Rice's telephone. You can see the same electromagneto idea. I will not go through this. These numbers and pieces are what are all the different areas Edison explored. For example, he explored dragging, And then dragging is a variation of rubbing to create the sound. And then switching between tones, some kind of induction. Okay? And then he had squeezing, that means pressure. Can you use pressure to do something? Then he came to the idea that it has to be an integrated transmitter and receiver, and that's where electromagnetograph came in. And he discovered this on his own, that if you have a loose carbon between two plates and changing resistances and magnetic strength automatically moves this carbon, which moves the diaphragm. Okay? And he was exploring that. And then with magneto, battery, he had a transformer, and then he created a combination transmitter. So I won't go into the details. This is based on the work by Professor Bernard Carlson from University of Virginia. Where
just a question. What do these numbers denote?
They are different ideas and explorations. There were a lot more than that. These were the ones that were revealed in the patent fight between Bell and Edison, and the time frame in which different ideas were explored. I mean, it says two in multiple places, the same idea coming back with a different way of looking at it. Does that make sense?
Yeah, fine.
Okay, you will see in a way. So what did if you go back, we said pressure here. There are 5 points there, but if you look at it, it is elaborated further in this case. Just the pressure required material search, diaphragm, resonance cavity, reeds. So all of this are the progression of his exploration. Okay? So leave the numbers out. It's a bit more complicated because the numbers are based on documents from the patent. Okay, in effect, what is going on here is that so he had dragging, rubbing, switching, induction, and squeezing. These were the 5 areas he explored. And he did this 2 patents to throw the competitors away from what he is doing, rubbing and switching. He patented them just like that, no intention of exploring. Then he had induction, squeezing became pressure, and you can see material search, diaphragm, all of these different areas were explored. And from there, he chose the rubber telephone. But then he was not happy with that. So he went back to the electromotograph all the time, loose carbon connection, and then he started looking at different aspects of it, and that he connected the magneto, the battery, the transformer, and continuous transmission into the battery telephone. Now it can go long distances. Okay, where was I? Yeah. Now what I did, I'm not going to go through this graph. Basically, I looked at all the concepts that were available at different points in time, and how some of them were combined together to arrive at the goal of soft and loud transmission, right? And different people were involved in this. It's very important to note that, because Rice came up with some stuff about variable resistance. Gray came up with actually creating the variable resistance system. Bell understood that he can use electromagnetic stuff to create sound, and Edison had a lot of experience in telegraphy, multiplexing. So you can see that different pieces were brought together by Edison, and they were all contributed by different people. Okay? So I was able to map the interaction between knowledge and the development of concepts in this particular case. Okay, where am I? Okay, this is the telephone. You can see the carbon powder. He had platinum discs to do the vibration. So it's quite sophisticated in terms of the different kinds of metal used and the connections made and the way sound was generated. What is his strategy? Composition and substitution as an invention strategy. The main moves used by Edison were composition, research, and substitution. He substituted devices from what he knew and from others he appropriated. He chose specific pieces to be improved. His planned research strategy broadly to solve conceptual problems as well as to generate knowledge that could be used in other instances. I think these are very important ways in which he went about doing his invention. So I'm going to, I've lost track of time. I better watch out. Okay, I have time. Now I want to show that how he thought about systems and devices at the same time, often. First, after he did the telephone, he went to a Italian telephone operator to set up a system. Bell sued him over the patenting of the telephone, and then eventually Edison and Western Union licensed the deal to Bell with the promise that they won't enter each other's market. So Edison was completely out of the telephone business. Now let's come to electricity. I mean, even the telephone story is longer, but I don't want to go into the details. So he started searching for bamboo fiber from all over the world, including Assam. He came up with close to 1,000 samples of bamboo from every place. So you can see that there was resistance from the academics saying that he doesn't, the professor doesn't believe that incandescence is possible in material. But he's happy let Edison do it, and he does it, right? And then he ends up with a vacuum glass bulb with a filament, and that's what his basic lamp was. Now what I'm going to say is I'm going to move this thing to a different level. I'm going to say not only he did devices and he had strategy, but now the way he approached it, I'm going to analyze it using the PSI theory of design. There is a problem, and what and why has to be established, and who should be brought together, and how do we operate. These three things are very important, and Edison understood this extremely well. So now I come back to this. He had a clear purpose, the drudgery he was solving, and that led to a cascade of problems to solve. So there was an unending source of problems he could look for and apply. Then he created an innovation factory. Think about it. He thought of it not as himself, but as a collective in which he is going to bring together not only expertise from machine shop, but also to create an R&D shop so that he can have a large number of people, scientists, machinists, all kinds of people in that shop. It was supposed to be an incredibly wonderful place. So anyway, he assembled people, and look at this. He says that there should be a small invention every 10 days and a big one every 6 months. He has created a certain ethos of search and looking for problems and trying to find new ways of doing it as an essential ethos of the country. That's sort of sets up certain institutional routines and all kinds of other things. So now, how did he go towards electricity? Now we talked about the R&D lab he created, and we now go to this thing. First, he wrote this out as an outline of a program and implemented it in 18 months. Method of generation and distribution of current, device electric lamp, measurement of electricity supply, system of conductors, even the pressure of the current, and a network of dynamos. Faraday had invented the dynamo, so he took that and figured out how to build a proper dynamo, which can be run, industrial dynamo, which can be run by diesel power or steam power or whatever engine you can use to run the dynamo. And then he was not just interested in how do I build the infrastructure. He was also interested in society and policy, in the sense he was the member of the group that decided the insurance rules governing the wiring, because there were incidents of fires and things like that. So he got involved in developing the insurance rules. He also understood that there has to be regulation on best devices and method for the system to become trust such industrial systems, they were providing electricity, and you don't want them to blow up. He also wrote the manual using growing knowledge of the installing software. Look at him. He's going from the conception to devices to writing the manual. Not only that, he wrote a paper on national economic policy and business. He was also for standards, because standards were an important part of being able to scale the process of electricity generation and distribution. And there was a huge project, which was the biggest fight between Edison and Tesla. Tesla used to work for Edison, and they fought over it, and Tesla walked away and went to Westinghouse. This was the largest hydroelectric power project that was conceived at that time. Tesla was working at Westinghouse. He demonstrated the advantage, and Edison lost, but he didn't lose it in an easy way. He created mock executions of dead bodies to show AC is more dangerous than DC. And it was quite a bit of a playing dirty to win his war, but eventually he lost anyway. So then Edison Electric cross-licensed it from Westinghouse, and they started expanding the electric powering of America in terms of equipment. So then comes this question, should we have centralized or decentralized power? Edison had been promoting decentralized power, but then he moved to centralized after the deal with Westinghouse. The problem with decentralized power was there was a lot of pollution from this steam, use of steam for powering the dynamo and other things. And this way they could move on. But the brilliance here is of his assistant, Samuel Insull. Both worked together. And instead of the state taking over or only being private, Insull came up with a wonderful public policy, which worked very well in the US, where it was an agreement between banks, industry, and public interest groups, so that everybody's interest is taken care of in such a way. And this was, it was called a regulated monopoly. And I remember when I came to this country, a lot of old people would have stocks in these kind of industry because they were assured a certain return. So anyway, it was very, very clever policy, which allowed for the creation of large power station and distribution. On the other hand, in Europe, made electricity generation and distribution as a state-owned enterprise. You can read the history in Hughes's book. And you can see Insull has produced a document, what is the role of public utilities in modern life. What is Edison and his innovation strategy? Continuous need to learn comprehensive knowledge across disciplines, and to have the notion of understanding of human needs and drudgery and industrial economics. He learned everything. He had some of the best minds in all fields working for him. All of them went on to invent things and run many electric power industries. Look at the way he brought knowledge. And really this quote says, a famous American teacher at one end of the log and the other end, and the student at the other end is the beginning of American university. Sounds like a little bit like Gurukula, but on a one-on-one basis, you can see how these things came out in the American system. Edison's Menlo Park was a laboratory, a university, and really a hotbed of innovation. How did he inform them? So he attended lectures of his friends in academia and technical places, Boston Tech and then Cooper Union. His strategy is mastery of the literature as a primary task of beginning an investigation. Everything done directly or related to it was collected and sifted. He never took the conclusions to be correct. He tested them, often completely different results, got completely different results using his own experimental methods. His guiding principles were economy and efficiency. Dr. Atchison, who was working to him, he went to Edison and said, I have failed. Edison's remark was, every experiment is a success, as in all cases, it cleared the atmosphere, even if it failed, right? Hypothesis tested is a valid hypothesis. Here, something doesn't work, is something you know for sure. Another thing he did was to motivate people. He put this everywhere. saying there is no expedient to which a man will not resort to avoid the real labor of thinking. So he emphasized the notion of thinking and learning and continuously evolving and looking for problems in a systematic way, from the devices all the way to building systems and implementing them in society. That is real innovation, in the sense you go from an idea to institutionalizing it in society. Very quickly, what do we learn from him? Innovation is a social and technical process. He works with diverse group of people with skills he did not have. He created the first R&D, tried to understand everything relevant to his pursuit, educated himself all the time and never stopped. He always thought about artifacts and how we'd make them available for use at all levels. Most importantly, he had a theme/philosophy to his exploration, removing drudgery in human life. It is the problem, people's need, that he wanted to solve, drove his research for the knowledge of the people he brought together. With that, I'll leave you with a small quote by this thing. Sorry, I have been mixed up in a whole lot of things, haven't I? Thank you very much. I hope I've given you a tour of his way of thinking and how he thought, how one could actually look at it and analyze it using these theories to get a history and evolution of how innovations took place. This is just a small experiment I did with Edison, and this can be done with other innovators as well. Anyway, thanks.
Thank you, sir, for a good overview of the Edison's journey, covering the two different technology developments, one on the telephone side and the other one on the electricity. So now I will open for any questions from the participants.
I'll stop sharing.
I must say that in spite of his varied interests, by getting in a whole lot of things, involved in a whole lot of things, he remained incredibly focused on everything he worked on and made advancements, so many advancements. And your presentation was really very good. To get into individual, each conceptual and knowledge advancement that lay behind his well-known scientific and technical developments that most of us, at least I didn't know about. Thank you.
Yeah, I find these people, actually, I didn't go through, there is another wonderful book actually by Carlson. It is called The Innovation as a Social Process, where he talks about this guy called Elihu Thompson, with whom we don't know at all, actually. He was in Philadelphia. He built the entire electrical system, and he also had the same strategy. He had created reading groups. He brought scientists and other people together all the time in order to expand the way he can build the electric power system. Incidentally, General Electric, he bought Edison Electric, and then it became General Electric, because he had mastered a lot of the technology from ground up, including distribution of power for street lights. So it's a very interesting, what I find interesting in these people is, how do they combine the knowledge? Where do they go search for the knowledge? And how do they go about doing it in order to go after, as you said, Sham, a very focused set of problems, right? And
but the electricity itself, like telecommunication, I think there is something inherent in that technology which is systemic in nature, right? You cannot, which might have pushed them towards looking at various elements and connecting things naturally. It
yes,
is not a product or something which one person can master, control, and produce, right?
Yes, I agree with you, but at the same time, the way there is another little history of an electrograph. It's like a movie thing. What he encouraged was, he had another person working with him, Dickerson. He told him to explore one way, and he explored it another way, and then they combined them together. So it's, and then not only that, one thing about them is they always thought about production. of the devices on a mass scale. Okay, whether it's the bulb or the dynamo or any of these things, how can we actually produce? In a way, they thought about it more in an end-to-end fashion. Almost all of the devices they built. He also invented the Portland cement, incidentally. That's a separate story. It's quite fascinating. I find same thing about Leonardo, the book Leonardo, the first systems engineer. It's quite fascinating in the way he thinks about things and puts them together in terms of systems. So to me, many of these people, these great people, were not thinkers in a narrow way. They thought about things in a very broad way and had an understanding of the interrelationship between how to translate a
No, but
device.
so if you were to compare with somebody like James Watt, right? So is there a parallel in terms of how the Watt's journey evolved? I mean, he is also credited with creating that first factory concept in Soho or somewhere, right? So he started with improvising the governor or the steam engine, and that's how we got into it. But then, is there a systemic characteristic to that problem, or that problem doesn't? Because railways again has the same issue. It is not, you cannot just build an engine and say it is done, right? Somebody has to put the track, somebody, right? It's
you are asking a very interesting question, and the person who has explored this beautifully is a guy called Anton House. He's on Substack. He traces the history of the entire steam engine. Actually, much before Watt, there were people in Europe who had already experimented with these things. It's again, if you go analyze it, you can see how people built one on top of the other too. And some of it, I forget this, the going from Watt's engine to actually implementing it. Apparently, there is a statue in Scotland where Watt, a very famous financier, and another person signed an agreement to buy his invention and translate it into production for the factories. I don't know the whole story. There is a whole thread there. The thing about Edison is he understood something else. Like, what did steam engine? Because of the science that was available at the time of Edison, he was very clever in combining the science as well as the craft of building these things. Right? That is a very important part of it, number one. Number two, he made investigation of knowledge systematic within an organization, not outside, fragmented in different places. So there are many innovations he has brought about in the way he thought about innovation itself. Right? So this has very good lessons for us. How do you build innovation laboratories? What are the interactions you want to have? And how do you construct them through both social and institutional means?
It's almost like creating a culture of innovation in the organization, which he did.
Yeah.
I have a question, another question, Sab. It's not exactly directly related to it, but it's indirectly related. It's a work of Tesla and Westinghouse. I mean, Edison's work was direct current. And these guys come up with the alternating current alternative as an alternative system.
Yeah.
Now, alternating current is not exactly an intuitively useful or correct alternative to direct current, you know. And the current is going back and forth.
It's flipping back and forth.
Changing
The
100 times a second. How could that possibly work? It was not exactly intuitive for anyone. How exactly did that come about? How did that idea that alternative current could be an alternative to direct current and be a better alternative? I've never understood that.
So essentially, that was the brilliance of Tesla. Tesla actually worked for Edison. He came up with AC current while he was with Edison. And this is an interesting story because effectively Edison threw out Tesla because he didn't like AC. And that also tells you sometimes when you become you believe that you have the answer to everything, you make stupid mistakes of not accepting somebody else's. And coming to your question of AC, the advantage of AC is that you are able to reduce losses because of the way alternating current allows you to keep the frequency and current flow steady. In the case of DC, if there is any voltage drop, automatically your current flow will diminish. So you have to have controls to make sure that 110 volts DC is constantly arriving at you. Otherwise, your lights will dim up and down. In AC, you don't have that problem because you're maintaining a frequency with which the interruptions are, even if you think of it as interruptions, don't matter.
I see.
Well-
But the peak voltage is greater than average voltage.
Yes.
That requires higher insulation and all that, you know.
Oh, yeah, right. That
No,
is
but
in our
yeah, one question is, did the problems with DC push for or lead to the emergence of AC, or AC emerged independently?
independently. This is a fight between Tesla and Edison within Menlo Park. It was a big fight. Eventually, Edison was so mad that he sold the licensing to Westinghouse and said, I don't want to do anything to do with this. And Tesla left. And if you go to Niagara Falls, you will see a statue of Tesla because it really dramatically changed. The other thing is also high voltage to low voltage. Stepping down is easier with AC.
Yes, of course.
Right.
Transformer.
Yeah, exactly. This is
But
what
now, today, because of solar, there is a tendency to go back to the DC, right?
This is a tricky problem. My friends work on this. See, what has happened is since marketization and decentralization, now you have a combination of sources and sinks. And the question is, how do you manage these sources and sinks, especially with intermittent power, right? Coming from wind and solar. So now you have to rethink this whole infrastructure in a different way because there are bidirectional flows of electricity. In the earlier system, everything was flowing downwards, right? Now, how do you manage this and how do you isolate them? All of these questions have gotten opened up. And you are right, it's a combination of centralized and decentralized power that we are moving towards. But even in the renewables, you can see there is a lot more centralization in terms of large solar plants rather than not as much in the local level yet. Now, this is a very interesting question as to how you manage these two things. And we also don't know how long all of these equipment we are putting last, 20 years, 30 years. Where is the refreshment cycle? You know what I mean? Renewing the infrastructure cycle. Yeah. But what I find interesting, so I urge people to read the lives of these people, at least one biography. I think your students also, if you can encourage them to read these biographies, they'll get an idea as to what does it mean to be inventive. And we used to do, yeah, go ahead. Somebody was saying something. Nobody is commenting from our audience. Anyway, I thought I'll take much longer time, but I ended up taking less time than I did.
Anyone in the audience wants to join the discussion or share something?
So I wonder, Sudhir, I'll try to get Bernard Carlson to talk about. He has written an entire book on Tesla, which took him 15 years to do. And he has one on Elihu Thompson. And these are people, but you can also look at books which talk about engineering, like Petrosky's book on To Engineer is Human, Failure as a Unifying Theme in Design. I feel that using these examples, if we are able to convince our young people failure is not bad, it's actually good, as long as you understand it through these storytelling narratives, could be another means by which we reach them.
Yeah, that's very interesting. You learn something from every experiment. There's no such thing as a failed experiment.
Right? Yeah.
That's very interesting. But or you could ask Elon Musk to talk about Tesla.
We don't want to go there. We don't want to go there. So anyway, you can. The other things about Edison, which I should say, is that he also had a big sort of white supremacist view of the world. He supported Hitler during the war until America jumped in. So there are all kinds of undercurrents, and the thing would want to understand is we should judge these people for the kind of things they were able to do and understand from what they did rather than judge them purely on their political views. And all of us have different biases, and what we can learn from these people is how clever they were in putting together their own methods, their own goals, and their own ways of actually exploring the entire space of innovation. It's a space of innovation. It's not just one innovation, right? That's the beauty of it. The theme gave them to open up problems forever. Anyway, I'll stop there. And
Thank you, Sab, for introducing this to us. Are there any other comments, questions from anyone?
I think there's something in reactions.
in the chat. Oh, somebody said thanks.
So if there are no more questions, then we could close it, Sam.
Yeah, sure. Let me stop recording, then